Yo, yo, yo. Yo, what's up, Derek? Hope you're having a wonderful Friday so far. And let's see if we can do some progress today. Okay, so it's still cleaning up of the water algorithm that's on the schedule. What do we have? I think I'm having a hard time to remember exactly what note I left on yesterday. Did we manage to roughly fix it? Let's see. Fuck it, let's just do a test run, see where we're at. I think we did. Yo, 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 what's up, Wesley? Hope you're having a wonderful Friday so far. Yeah, now we have sand. That's something. What do we have? Height 312, so 9. Let's see. I think we also need to do, let's see here, move data water to water previous. Probably want to clear some data as well. I'm talking about water temporary here. Other than that, I think it's working good. Yeah, I think we're actually going to clear water temporary at the end. So like after everything, I think, because the last step of this algorithm will be to move the data we have in water temporary to water, and while we do that, we might as well clear it. I wonder. Let's see here, terrain, data container, move data, swap data, alter data. Alter func, source transform func, alter func, reset source. Yeah, so what I'm saying is we can just reset it here. But I wonder... So the step final, I want to do this something like environment controller, terrain alter data. We want to alter water, or actually we want to take from water temporary, put it in water, and source transform func is probably just going to be return s, and alter func. Oh, fuck. It's actually, I think we have a method for this. Set data. Oh, no. Move, swap, and alter. That's what we have. So in the end, we just want to move data from water temporary to water and reset source true. Just to make sure that we're clearing this one and that the previous water is in this one. And I'm also wondering, at the beginning we do move data from water to water previous and we don't clear water here, and that is, I think it's the correct decision because we want to add to it. I want to be able to implement like the addition of water, although I wonder okay, let's see what kind of result we have now. But no matter what, like the initial water amount we add pretty much only yeah, no matter what value we set, I think it will always only disperse 0.25. Right now, let's double check it. And that's good. That's how I want it to be. So right now it's pretty much the functionality that we find the minimas, and how long we walked is decided by the water amount we output. And then at every minima we find, we store them, and then we set the input to 25. And then also we calculate a final fluid amount for let's see here, the minima. Yeah, we put it in water. Yeah, so the idea is we find every minima. For every minima we find, we add 0.1 water, and then we're gonna add it here instead. So the water we have in source, we add with what we add, and then we calculate this shit. And that's the final water amount we get. Although something like that. We're gonna have to do some other stuff as well. But yeah, I think it's okay. For now. Okay, let's see. Height 6, 18, 12. Let's see, height 14, height 6. So we lose 8, so 10 minus 1, yes. And what happens if okay, that's good. So currently we can only add this much water. Oops. And if we add more water, we will reach longer. It's taking a lot of time. The fuck did we have on the timing there? That's not good. Oh, actually, it seems to be... Oh yeah, we're not removing minimas. We need to fix that as well. But let's see here. Prep. Minus 94. That we need. I think it's okay. Let's see here. Finding minimas. 0.16 seconds. That's good. 6 seconds. I think we're okay. I think the most amount of time here is the adding of game objects, so that's still okay. it went into multiple pools as well, so that might be the reason. Yeah, definitely. So I think we have the biggest reason for the time is the instantiation of the debug objects. We're pretty much instantiating. Can I see how many it is? Yeah, we're instantiating all of these objects. So that's a big chunk. And also, as you say, we went into multiple pools. So if we take a look at here, we're finding minimas, and then every time we do steps 2.1, this is for each minima. And what this tells me is that we're not removing, after we have done calculations for one minima, we don't remove that minima from the minimas list. That will probably speed it up a bit. When we add water, let's see here, when we add water here, yeah, now we're removing objects as well. And we're printing a lot as well. But when we're adding water here, we should eventually, let's see here, what was the final time? 8 seconds, yeah. So when we add this much water here, we should only get 1, 2. I think we should only do step 2.1 2 times. Currently we do it a lot of times. So yeah, let's just take a look at that real quick. I want to see. Yeah, so unvisited points. Eventually we want to do something like this. Final points dot remove n. I just want to see what we get from this. So if when we do the part where we find where we find fluid limit per minima, if we traverse a point that is in the minimas list, we also want to remove it from the minimas list, so that, because we were filling it with water, with more water probably, most likely, than we will actually add in the end. So if we add one here, there we go. But then we get a result like this. It works good here. Okay, that makes sense. Yeah, it makes somewhat sense. $95, $97, $98. Although I wonder why we don't walk more in this direction. Or actually, I know. Let me just check. We do finding of 1, 2, 3, 4, 5, 6, 7, 8. We do it 8 times. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Still. So this, weird as hell. Finding overflow limit cost base 1. No, actually, everything is okay. Yeah, okay. So when we find a limit, yeah, okay. So this is not the final water. This is the here we represent the limit algorithm. So I think still let's see. So when we find the limit, spread fluid to neighbor, or actually I want to do calculate spread cost to neighbor. Yeah, currently we do, if height difference is bigger than 0, i.e. we move downwards, we do cost down times height difference. This one is 0, but we do cost plus equals to, so it's costly to move downwards. That's one change I want to do. And the second one is this one. We don't want to remove it here because this step, so the step we're doing here, is to calculate the maximum amount of fluid we can add without overflowing. So we want to do one last step here where we actually add that much water. So yeah, let's just add that step and see where we're at after it. Let's see, unvisited points. Yeah, we have M. So after this step, do we need to change water temporary? I don't think so. So we do We add m again, and then we do while unvisited points count is bigger than 0 once again. And basically I think this is the easiest step, because when we enter the last step of the algorithm, we know which minimas that will hold water, we know how much they will hold, so now it's just about spreading that water in a nice way. Let's take a look at Fluid Solver. Remove already visited minimas. So it's basically this we're gonna do now. Add fluid amount, final fluid amount. Final fluid amount. Yeah, we want to do this. Yeah, so when we get to this one, the last step, we're actually going to do this. Let's see here. We add it back in. Okay, do it first. So we do this. M dot terrain patch, terrain data, set data. And now we're actually going to set the water. And the value, we have an int value here, that's good. Final fluid amount, apply false. So when we do the last step now, we're going to do it on the water directly. So this one we probably don't want to do in the end. I'm just wondering. Do we have move data, set data? Yes, we have this step as well. But I'm wondering about this one. We're gonna hold off on this one for a while. So this one is basically about adding the correct amount of fluid to the edges so that the mesh itself becomes nice-ish. But I think we're gonna fix this one in the shader anyway, so we might skip that one. One sec, quick, be right back. Okay, back, sorry about that. Let's see. Yes, so in the last step we know how much or the maximum amount of fluid we can add. We know at what points we should add it. And that's why we're going to go with a cost rule of, like, moving in parallel in the last step costs 0. And yeah, so the last step, the most easy one, we pretty much just do a flood fill. And I wonder... Actually, yeah, here we want to... do we? I don't think we care about moving in the correct the direction for the last one, so we might as well just... Okay. Let's grab this one, put it in here. Zero, 1, 0, I think we're gonna go with. Dim Low, thank you for the follow, appreciate it. Okay, so let's see here now. We need to get the first point. We need to get its height, then we remove it. Loop through the neighbors. Get terrain patch. If end terrain patch I don't care about this one this time around. Get neighbor height, calculate height difference, calculate cost. But here we want to switch these. Final fluid spread. Spread fluid to neighbor, TP and cost. If that succeeds, we add it. If it doesn't succeed, we don't give a fuck. But if it succeeds, that means that we alter the fluid amount on that point. And if that point is a minima, so final points dot remove. If that point is a minima, we don't want to go through it later on because we add it with water from some other minima, so we remove it. And that is about it. So finally, we're gonna remove these visuals. We're gonna remove these visuals. Finish step 2.2, setting final fluid amount. And I want to show terrain data type water. Although, yeah, we have one problem here I need to fix. Yeah, we want to do terrain data type water, but spread fluid to neighbor, this one always spreads on water temporary. So I actually want to add terrain data type here, type. And then we just replace these. With type. So now we have an error here, and I want to fix this and set terrain data type water. Water temporary. Okay, add fluid. It's rough. It's a lot of duplicated code, but. I think we're gonna clean that up a bit. I think. We can probably hide, first of all, this one. So right now we define a tuple, we change a variable on the tuple, we change another variable on the tuple. Yeah, I want to try this, I just want to double check. Okay. Yeah, that's what I thought. So instead of doing all this stuff, we might as well put it into a method, create some tuples. So like creating one, altering one variable, then another, and then a third is not the way to go. So that means that we can clean this one up quite a lot. We can remove a lot of duplicated code. That's nice, but let's see what we have here before I do that. Oops. So what did I miss? That's not what we want at all. Yo, what's up, Little Miss Murder? Hope you're having a wonderful Friday. And I hear you. I hear you. Yeah, something is wrong here. Finding overflow limit minus 128. What the fuck? Zero. Let's do terrain fluid solver. Yeah, there's a few things wrong. My cat has been missing for 3 days, not having the best day. Oh, I'm sorry. Has it been missing previously for an extended amount of time, or is this highly unusual? And get cracking so I can collect my cat. I will try. I will do my best. Yeah, this is not the result I anticipated. I'm wondering, finding overflow limit here. Final fluid amount. Yeah, what the fuck is going on? We're gonna get to the bottom of that. I just need to... Yeah, okay, this one... Yeah, we have a problem with this one, I think. Yeah, we do. And also, I want to do... If final fluid amount less than or equal to 0, continue. I moved into a new place. It was fine for the first few days, then I guess he went wandering and got lost. Yeah, I'm sorry. Hopefully he finds his way back. I'm a little bit worried about this one. I don't think we... Because putting the water temperature data into water screws it up for us. Down here when we start working with water. So what we're gonna do instead is... I wonder Water temporary. Yes, cats have that arsehole streak in them to make you miss them for a week, then they come back. Yeah. Yeah, I had some friends that lost their cat a year ago, I think it was. They found it eventually after, I don't know what it was, 3 days. Turns out the cat has entered the neighbor's home and lived there for a couple of days because they were on vacation. Okay, putting water temporary in water screws us up. I wonder if... Fuck, am I gonna have to clear source? Probably. My Siamese cat found a nice old lady in the previous neighborhood where he used to cozy up and get fed lots of unhealthy treats. Yeah, that sounds like a good life. Okay, when we find new final fluid amount here, we do that using water temporary. Probably want to clear water temporary here. But move water temporary to water. We do max. I think we just want to move it to water previous. But then we won't be able to visualize it in a nice way, so that's wrong. I mean, what we could do is set okay, we take water temporary, we set it in water, but we do max, we're gonna do add later on. Then we want to work with water temporary is zeroed out. So then we work with water temporary in step 2.1. And that's okay, but when we're done with step 2.1, that's when we want to alter it once again, or we want to clear the result basically. Although I wonder, Water. I wonder if we just might as well do. I should be able to make this work with the data switch we have right now, but I just wonder, where does it go wrong? Spread fluid to neighbor. N fluid is new is bigger than N fluid. Or actually, yeah, the hard part here as well, or something that makes it a bit more complicated for us, is that we don't want to do a environment controller terrain alter data call, alter, swap, or reset, or whatever, between step 2.1 and step 2.2. And we want to do this because I think we want to visualize this one right here. Otherwise we could just do, I guess we could do something like, do we have, no. Or I wonder, Probably don't want to rely on this one in the end, because basically what we're doing now is we're sending the data to the GPU between these. So what we could do is control the terrain, alter data, water temporary, terrain data water. So we do this. And we also do true. So we move water temporary to water, and then we apply it so that our GPU gets this updated data. And then we could do move data but we probably want to clean this up a bit later on. This is probably not what we want to do. Like, when we have done find minimas, then we want to visualize this, and we want to do it by, we're going to interpolate in the shader, we're going to interpolate between the data in water previous and the data in water. So we don't want to switch it right after, but we want to do this. Water temporary here. Or actually, could we? Move data, terrain data type, water to terrain data type, water previous, reset source true, apply false. So we alter data, we take whatever, we find minimas, and then we take whatever result we have in water temporary, put it in water, and then we apply it, so the GPU has the texture where water temporary is moved to water. So that one will be able to animate it in a nice way. Then on the CPU side of things, we move the data in water to water previous. And then we do step 2 prep. Ooh, yeah. Water temporary is cleared, and then we do this. We set data in water temporary. We do calculations on water temporary. And then we do calculations on water. Water should be cleared this time around, so maybe. Prep, find minimas, prep, finding overflow limit 0, 0, 0, 0, okay. Zero, zero. So all overflow limits we find are 0. Yeah, I think that would be the case here. Not here, though. Yes, because we're getting the data from water here. We want to change this to water previous. Do we want to get... Yeah, we do. Okay, better. Water 12, water previous 25, water temporary 22. And we do... Fuck, quick as hell. Let's see here, what do we have? Step 1 prep, find minimas. Prep, finding overflow limit minus 128. That one... I don't know. Minus 128. Is that an overflow we have? No. Okay. I think we have some data laying around, screwing things up. Yeah, water previous 25 here. That's not true. Or actually it is. It depends on if we want to reset it or not. But yeah, we don't want to reset it. Like if we already have water here, we want to work with it again. And we always want to flow in the direction of fuck, am I being too what is the word I'm looking for? Am I being too lenient on the initial pass? So like if we add water here or here, we find this minima and this minima, but the water would probably it want to move in the direction with the biggest downward gradient, right? So if we add water here, let's see here, we should not be finding this minima. It should go straight down to this one. And that is probably the only minima we need to work with, I suppose. But if we add water here, that's another. No, it should find this one. And maybe I'm being too nice. Yeah, I am. Hate this visual as well. We need to figure out how to get rid of this one. It's okay, but I wonder. Okay, so if we add water here, probably want it to pile up here, actually. Okay, so right now when we add water, we find all minimas, then we sort them based on the fluid amount that reaches it and the height of the point. So when we try to find a limit later on, we try to do it based on the one with the highest fluid surface height. But I wonder if when we do the minima search, if it would be better to just find the minima with the lowest height, because that's where our water, that's the what the water is going to reach. And just go with that one. The only problem in that case would be here, for instance, I guess. Or more likely here. Like when we have a case where the water can go either way, then it will always take the lower one. Am I okay with that? So in this case right now, oh, let's see, this one, yes. The question is, do we find this minima? Probably. So this one, for instance, what kind of result do we get here? Can we fill this one up? Yeah, this is the result I think I want to skip. So basically, if we add water here, the water will reach both this point and this point. This one will have a higher fluid amount and a higher height. So we will start by filling this one. If I added water here, I would probably only want to fill this one up like this. I think it's an easy thing to fix. We just need to sort it based on height in ascending order, and that's about it. But solve this issue as well. I want to get this result, but like if we add water here, I don't want to get this result. If we add water here, I probably want to get this result. So yeah, need to find minima. With the lowest height. And if we change the algorithm, so right now we move in the direction of the least costly when it comes to fluid. So and it's always cheapest to go downwards. 10 1 0. I want to try one thing here. Step 1, find minimas. I wonder if we want to do yeah, I don't want to exit at the first minima we find. But we just want to do the rest of the algorithm for, let's see here. So final points ordered by descending. Can we do so what if we instead did order by descending, order by, and we just do this one. Find all minimas we reach, order them by height. So we get the lowest one first. And then If we go with this one, I would probably want to... Yeah, if we want to visualize this one later on, we're probably gonna have to do some extra steps. But I think that's okay. And then I wonder if I can just do... take 0 to list. So we just take the first one as well, and then I wonder how I want to handle this. I probably don't care about changing this one. So if we do it like this, we will always only have one final point. And that sucks in the case where we add water exactly in the middle of 2 minimas and we want the water to spread to 2. But I think we can fix that in some smart other way. So we could, for instance, when we find minimas, we could increment we could do it like this, but we increment the base cost based on the let's see. Yeah, I don't know. Let's just see what happens with this approach instead. Okay. Oh, yeah, we want to take 1. fuck. Do we actually walk that far? Okay, we walk extremely far and we find the lowest one, definitely. What do we have here? Height. One, so I guess we have a height 0 here, I'm pretty sure. Yeah. I don't see... Adding water here. Do we really walk this far? I don't know. Yeah, if it's all downhill here, yes. That's too far, that's too far. Probably want to do... Like if I add 0.1 water here, yeah, we definitely want to end up here. But if I add 0.1 water here, we probably want to end up here. But this is just a cost problem. So depending on how we change these variables, or more specifically, cost down multiplier. It's all about how we handle flowing downwards. Right now it's free, and that's why we always reach extremely far away. But we want to do it in such a way that cost down multiplier is based on the base cost, and the bigger the gradient downwards, the more we remove from the base cost down to a maximum of all of it, basically. So cost down times height difference. We want to do mathf.clamp between, what do we have here? So the value first, we're going to go with cost minus this min 0 max 255. So the bigger the height difference, the more we remove down to a cost of 0. Yeah. Redacted on top, what's up? Yeah, I'm talking. Thank you for the follow, appreciate it. Nice voice, appreciate it, appreciate it. I'm doing fine, I'm doing fine. How about you? Is this how we want to do it? Yeah, this is, I think this is probably correct now. So if we add water here, if we add water here, 19. One sec though. Yeah, right now we have finding minimas, cost base is 10, cost up 1, down multiplier is 0. So right now it costs, moving in parallel is as expensive as moving downwards. Does that make any sense? So where the hell are we getting this result here? That looks so clean, to be honest. Thank you. I like the positive energy you're bringing. Even though you're only doing okay. Yeah, this result boggles my mind. Definitely. Or no, it doesn't. It doesn't. But let's see here. Water 10. We add 25, a water amount of 25 to this point. We get 10 eventually. Why? Oh, I know why. I know why. So, when we find the limits, so the amount of water we can add without overflowing here, we base it on, or we actually use the new way of calculating down the cost of moving downwards, which is, we have a 0 multiplier here. So we want to do I guess we could just max this one out to 55. So that means that it's free moving downwards now. Still. Water 12. Yes, and we have this one as well. So let's go 255 there as well. Now we should be seeing a water value of 25 here, definitely. Much like this one. So what's happening? Prep 1, we add fluid amount 0.1. We set this data, so 25. And then we find the minimas. This shouldn't be no problem. What do we do then? And then we order them by height. Should be okay. And then we set water temporary to, or we move whatever we have in water temporary to water. If it's bigger than 0, we set it to 25, otherwise 0. Then we take the max of source and destination. Should be okay. And then we move water to water previous. And we clear it. Then we take water previous. Final fluid amount. Yeah, this one has to be... I think we're calculating this the wrong way. Unfortunately. Ooh. Water 21, yeah, I think that is as good as it's gonna get. Water 12, height 21. Yeah, this one is, yeah. Okay, that's better. And if we add water here, this is the result we get. If we add water... yeah, if we add water here, we don't get a pile up. If we add water here, we get a pile up. So if we change... we want to change this one as well. Finding minimus cost down multiplier, let's go with... So if we move downwards 5 steps, it's going to be free. So anything above 5 steps is going to be free. So yeah, if we pour water here, we will get to this point. If we pour water here, we will pile up here. I think that's good. Still... This one, however, yeah, I think it's still good. Okay, let's do this. So right now we're not we're not trying to calculate adding water to water that already exists. So I think we're gonna start with a move data, swap data channels, alter data, clear data. Yeah, so by clearing the data, I mean we just set it to 0. I think that will work. Terrain base. So before we do anything here right now, we're gonna do environment controller, terrain, clear data. We're gonna clear water. Water previous. And water temporary. So we pretty much don't need to do this, but we're eventually gonna need to do this, so I'm gonna leave it there. Oh yeah, we need to fix this one. This one is rough. Don't we have any minimas here? I think we should have. Around here at least. One. Oh, actually, cost down multiplier. Yeah, we don't want to go with full numbers here. We want to do between 0 and 1. I would think so. Maybe 0.1. This one right here should be a minima. But okay. So yeah, we add water there. 25, but it probably doesn't reach. Yeah, when we try to calculate how far it will reach, we're probably gonna exit, because 25, an amount of 25, if we move downwards, it's gonna cost a lot. Yeah, we definitely want 255 here, maybe. This one is what worries me the most. We should be getting water here. This one works, this one does not. Okay. So when we add water here, we find minimas. We find a few minimas here, and then when we start to walk through, like we want to find the maximum amount we can fill, we start walking downwards here and we find a point. Or actually we don't exit the algorithm in a good way. Basically all the water dries up before we reach this point, which means that we won't add any water. But that is wrong. Finding overflow limit case base, cost up, multiplier 1. Are we actually moving that many steps? Could it be more than 25 steps here? Do 5, 10, 15, maybe. Could that be it? Limit base cost 1. $255, so anytime we move downwards the cost gets nullified. So we should be able to reach this one, I think. Oh. Water temporary 8. Yeah, we should. Water temporary. Finding overflow limit minus 64. Yeah, that's wrong. minus 64. Final fluid amount. Lowest unreachable height. This one should work. N height minus M height, yes, and that's only if this one is bigger than this one, and that's not true for this case. This one might be though. N height is less than lowest unreachable height. One sec, quick, be right back. Okay, back. Sorry about that. I think the problem is... fuck, I don't know. Lowest unreachable height. Final fluid amount becomes minus 64, was it? Or 128, 64. N height is always bigger than M height, so this one can't become negative. So it means that this one screws us over. I wonder. Height 128, I guess we have height 64 here. Height 0. 32, 64. So we only reach... Oh... Yo... Do we... Okay, if we move like this, and then if we move here, and then we move here. So when we move from this point to this point, we probably dry up. And that's not good. So we dry up by moving in parallel on a point that has a height that is less than our minima. Lower height. Good morning, Desai. Hope you're having a wonderful Friday so far. So this one is 64. Is less than this one. 64. We calculate new fluid amount. 64 minus 128. Yeah, minus... Yeah. This one screws us. I wonder... Yep, and I hope the same for you. Thank you, appreciate it. Yeah, this is plain wrong. What is it I want to do there instead? Oh yeah. Highest point helps us out here. But yeah, so I think I have the question to... So the question to this, or the answer to this question is yes. But I still don't know. I think the problem we have at hand, like, I think I can solve it pretty easily. But now it also becomes a question of how do I want the fluid to work? What I'm afraid of is a case where we add water to an elevated point. We have a local minima there. That minima overflows and it goes down to an extremely big area. We probably want to fill that area as well. But we have to stop it at some point. And I think we're just being too tough on where we stop it. But with a base cost of 1, we can at most move... Yeah, if we add an initial fluid amount of 25, we can at most move 25 steps, and that sucks. We need to be able to move more than that. Which means... I think it's maybe this is exactly how I want it to work. If we just add a value of 25 here, it's not enough to fill this one up. But if we add a value of 50, it's definitely enough. So we don't want to do this here. Water temporary, if it's bigger than 0, 25, otherwise 0. We don't want to set 25 here, we want to set fluid amount. Something I should have done a while ago. Because that's the initial, so I just want to try fluid amount. Fuck. Oh yeah. Water temporary. Terrain patch start, water temporary. Yeah, let's do... I don't think we need to... Yeah, fuck it. So we add water, we walk a distance based on the initial water we add. When we find a minima, we add the start fluid amount to that minima, and then we start calculating how much it can spread without overflowing. So and what we do, finding overflow limit 0.1. Maybe. Water 0.1 here adds nothing. 0.2 adds, that's great. That's good as well. We have a minima here. Oh, beautiful. But if we instead add water here, we get this result instead. Great. 0.2, 0.2, 0.2. Nice. We should be able to add it somewhere around here. Maybe if we, yeah. 0.1. So if we add 0.2 here, we don't get to a minima. But if we do 0.2, or actually 0.1, yeah, we float there, great. If we add 0.1 here, yeah, I'm okay with this. Oh, exactly how I want it to work. What the fuck? So if we add 0.2 and then we add 0.5 here, 8. Okay, this one. Okay, if we add here, we actually get, that's bad. Cost up multiplier 2. 3. What the fuck, 10. This is probably a case I want to solve. So if we start here, we actually have enough fluid yeah, if we start here, we actually have enough fluid to pour down here, but yeah, that looks weird, right? That's a problem we need to solve, but other than that, I think we're good. Beautiful, beautiful. And the more we add, great. Okay, I think this is a we have a few small problems, but I think they are easily solvable. Now I think we have the water behaves in the way I want. So, and now we can move on to, or we're gonna fix these two small issues. And then we're going to move on to incrementally heightening the water. So the first time we add water, it's going to be 0.1, the second time 0.2, the third time 0.3, and then the player will choose to wherever he or she wants to stop. Exciting. Okay, so this is a good note to end on, because I gotta run. Wow. For the first time in quite a while, I can actually see the end, or the light in the end of the tunnel. And where tunnel is this water terraforming stuff. So that's exciting. But yeah, as always, thank you so much for watching, everybody. Appreciate it. And have a great weekend. Peace. And thank you for the follow, Mad. Appreciate it. Yeah, have a great weekend, everybody.